All right, so today we're going to do just a little bit of review. So we are going to, first of all, review how to write electron configurations. So there are 4 examples here. So let's start off with magnesium. Again, use your periodic table to help you figure out where to start from. All right, so if you remember, you always start at 1s. So for magnesium, we'll do 1s, and there are 2 electrons in 1s, so we do 1s2. And then after 1s, we move on to 2s, so we go to 2s2. And again, I'm just looking at my periodic table, reading along. After 2s, we move to 2p, and there are 6 electrons in the p orbitals. Next is 3s, and if you notice, magnesium is the second element in the 3s, so we put 3s2, and then we are done. Okay, so now let's try phosphorus. Okay, phosphorus is in the 3p sublevel, but remember, when we're doing electron configurations, you always start at 1s. So we're going to do 1s2, followed by 2s2, and then I'm still just reading along. So now next is boron, starting in 2p. So 2p, and there are 6 electrons in 2p. After 2p, we move on to 3s. There are 2 electrons in s orbitals. Then we move on to 3p, which is where phosphorus is located. Phosphorus is the third element, so that means it is 3p3. Okay, now let's go on to bromine and xenon, and for these I'm actually going to, we're actually going to start doing it the shorthand way. So bromine is in the 4p sublevel, so we're going to do it the shorthand way, which means we need a noble gas. So you put your finger on bromine, you go all the way up and all the way over, which means we are starting with argon, and we put that in brackets, and then we continue. So after argon, we move on to the 4s orbital. 4s orbitals contain 2 electrons. After 4s, we move on to 3d. d orbitals contain 10. After 3d, we get to go back to 4p, and bromine is the 5th element in 4p, so that means it is 4p5. So now let's try xenon. Again, xenon is number 54. Xenon is a noble gas, so to do the shorthand for xenon, we still have to go up one row and all the way over. So this time we're going to start with krypton. After krypton, we do 5s, and there are 2 electrons in the s orbitals. Then we move on to 4d. d orbitals have 10 electrons. After 4d, we move on to 5p. Xenon is the last element, so we do 5p6. So that's how we do electron configurations. So now let's look at number 26. Number 26 is asking you to identify an element that is described by the following characteristics. So if we look at A gives you an electron configuration. So again, I'm going to use my periodic table while I'm doing this. So as I look at my periodic table, I need to look at the last filled sublevel. So 3p is the last filled sublevel out of that electron configuration right here. That's the very last one, which is not always listed last, so you have to kind of remember the off-bow principle. But if we look at 3p, 3p starts with aluminum, but we're at 3p4, so we have to count the 4th element, so that makes A sulfur, because it is the 4th element in 3p. B says it contains a full second energy level. Well, noble gases have full energy levels, so we need the noble gas in the second energy level, which is neon. C says contains the first d electron. Well, the first sublevel that has d is 3d, and the first element in 3d is scandium, so that's the first element that contains a d electron. Letter D says it has to contain 7 electrons in its 4th energy level. Well, we have to look at our 4th, and if we're doing 7 electrons, we know we not only are looking in 4s, but we also have to look in 4p. So 4s starts with potassium. So potassium is the first electron. Calcium has 2 electrons in the 4th energy level. Now we have to jump over to 4p. Gallium has 3, germanium has 4, arsenic has 5, selenium has 6, and bromine has 7. So bromine is going to be the one with 7 electrons in the 4th energy level. The next one says it contains only 2 electrons in the 5th energy level. So we're looking in 5s because S can only hold 2 electrons. So if we're looking for only 2, we have to look in 5s. 5s starts with rubidium. So rubidium has 1 electron. So then strontium, which is Sr, is going to have 2. The next one says it contains 3 unpaired electrons in the 3rd energy level. So basically, remember, the 3rd energy level, unpaired electrons, we are looking at P because P has 3 orbitals, and you have to put 1 electron in each orbital before you can go back and pair them. So in the 3rd energy level, we look at 3P. Phosphorus has 3 electrons out of a possible 6, which means we're going to put 1 in each orbital before we go back and pair them. The next one says it contains 5 electrons in its 3D orbitals. So if we look at 3D, 3D again starts with scandium, which is number 21. And we're looking for 5 electrons, so we just count. Scandium is 1, titanium is 2, vanadium is 3, chromium is 4, and manganese is 5. So our answer for G would be manganese. And then H says it has its outermost electron in 7s1. So 7s starts with francium. That 1 in 7s1 means we only have 1 electron, so we're looking at the first element, which is going to be francium. So that is how we go about reading the periodic table. And again, I'm sorry I can't have the periodic table up on my computer at the same time. So now let's move on to the next question, number 27. Number 27 is asking you to do a little bit of math. So let's see here. Number 27 is asking you to solve for frequency when you're given wavelength. So we're going to be needing to use the C equals frequency, or wavelength times frequency, and then we're just going to plug in our numbers. C is a constant, so it never changes, so you're going to have 2.998 times 10 to the 8th meters per second. Okay, we know our wavelength is 6.25 times 10 to the negative 5th centimeters, but centimeters is not going to cancel out our meters, so we have to first convert this to meters, which most of us just like to move the decimal. So if we're converting this to meters, we're going to move our decimal twice to the left. Okay, so we're going to have 0.0625 times 10 to the negative 5th. So we are solving for, we want our frequency. We have our wavelength, and I'm afraid I'm probably going to run out of room. So we're going to put that down here. We're going to do 0.0625 times 10 to the negative 5th, and now we have meters. Alright, so now all we have to do is math. So now frequency is being times by wavelength, so to solve for frequency we have to do the opposite. So we're going to do 2.998 times 10 to the 8th divided by 0.0625 times 10 to the negative 5th, and we should get our frequency to equal 4.80 times 10 to the 14th, and our unit is going to be hertz or 1/seconds, whichever you prefer. Alright, so let's look at the last problem now, and I'm going to have to erase this so that we have plenty of room. Okay, so number 28 says, what is the energy of a photon whose frequency is 5.2 times 10 to the 15th, s to the negative 1, which remember s to the negative 1 is telling you that we're dealing with hertz. And so I'm going to do my work over on the right side of the screen so I have more room. So we're going to need to use the energy equation. Energy is equal to h times our frequency. Luckily for us, they gave us frequency, so all we have to do is plug in our numbers. Okay, h is a constant, Planck's constant, and it is equal to 6.626 times 10 to the negative 34th. Okay, and our unit for h is joules times seconds, and we are going to multiply that by our frequency, which they told us was 5.2 times 10 to the 15th 1 over S, which is the same as Hertz, so all I have to do is plug this into my calculator. Remember your significant figures. 5.2 only has 2 significant figures, so my answer can only have 2. So I'm going to round what the calculator gives me to 3.5 times 10 to the negative 18th. My seconds cancel out, so I am left with joules. Okay, so now let's move on to the next problem on the back side. Well, I guess this was the back side. So now let's look at number 21 on the other side, on the front side. Alright, so let's look at number 21 now. Again, I'm sorry I did this a little out of order. But number 21 says, write the electron configuration for these atoms. Using arrows to represent electrons, then use the shorthand method to write the configuration. So basically, this problem is asking us to draw an orbital diagram and then write the electron configurations. So let's start working. So for sulfur, we need to draw an orbital diagram. So again, look at your periodic table. Sulfur is in the 3p sublevel. We always start at 1s, but we need to end at 3p. So 1s, s has 1 orbital, so I'm going to write 1s, and it's going to get 1 line. After 1s, we have 2s, which again gets 1 line because it's an s. After 2s, we go to 2p, which gets 3 lines because p has 3 orbitals. After 2p, we move on to 3s, which again gets 1 line because it's an s. After 3s, we go to 3p, which gets 1, 2, 3 lines. And now we have to figure out, now we get to stop because sulfur's in 3p, so now we have to add our arrows. Sulfur is number 16, which means we need 16 electrons. So following your rules, we're going to plug in arrows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the orbital diagram for sulfur. Next, it was wanting you to write the electron configuration, which is honestly taking the information and then just writing it in a shorter-hand way. Again, starting at 1s, so we have 1s2, 2s2, and I'm just copying down what I just drew. In 2p, there are 6 arrows. In 3s, there are 2 arrows, and in 3p, there are 4 arrows. So there's the electron configuration. Now let's do one more practice. Let's practice doing the shorthand way, in which you have to use a noble gas. So if we put our finger on sulfur, if we go all the way up and all the way over, we're going to start at neon. After neon, we have 3s2, followed by 3p4. So that's how you do the shorthand for sulfur. So now let's look at neon. Okay, so first we're going to do the orbital diagram for neon, or for not neon, sodium. Sodium is in 3s, which means I need to start at 1s, end at 3s. Again, 1s has 1 orbital, so we draw 1 line. After 1s, we have 2s, again, 1 line. After 2s, we have 2p. p orbitals get 3, 1, 2, 3. After 2p, we get to go to 3s, which just has 1 line, and sodium's in 3s, so we get to stop. Sodium is also have an atomic number of 11, which means if it's neutral, it has 11 electrons, so we need 11 arrows. So following the rules, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this guy has 11 electrons, and so the 3s orbital only is half filled. So now I need to write our electron configuration, which is giving you the same information, just in a different format. Start with 1s. So 1s, 2 for 2 arrows, 2s, 2 for 2 arrows, 2p, we have 6 arrows. After 2p, we do 3s, and 3s only has 1 arrow, so we just put a 1. Let's go ahead and do the shorthand method. The noble gas that is before sodium is neon again, so we put neon in brackets, and then we continue on with our electron configuration, which is 3s1. All right, so now let's look at number 22. Number 22 is asking you to do another wavelength frequency energy problem. So,
may I have your attention, please? Students who would like to speak with a representative from Park University, please report to the counseling conference room at this time. Thank you.
okay, so for number 22, we need to solve for frequency. So we're probably going to be using C is equal to our wavelength times our frequency. It gave us our wavelength is 2.4 times 10 to the negative fifth, but again it gave it to us in centimeters. So we're going to have to move our decimal over twice, add a 0. Right? So C is equal to 2.998 times 10 to the 8th meters per second. Okay, our wavelength was given to us as 0.0240 times 10 to the negative fifth meters now because we converted it, and we want to solve for frequency. To solve for frequency, we just do the opposite. So right now it's multiplying, so we're going to divide each side by 0.0240 times 10 to the negative fifth meters. Do the same thing to this side. So we should get our frequency when you put this in our calculator. And again, we can only have 3 significant figures because 2.40 has 3 significant figures. So we're going to round what our calculator gives us to 1.25 times 10 to the 15th. Don't forget your unit. This is frequency. So our unit is hertz or 1/s, whichever you prefer to use. All right, so now let's look at number 23. Number 23 is asking us to again identify elements that have the following electron configuration. So how I do this is I honestly just look at the last filled energy level. So if we look at A, our last filled energy level for A, let's see, 1s2, 2s2, 2p, 3s, 3p. Okay, so our last filled sublevel is 3p, and it's the first element because it's 3p1. So if we look at 3p1, we're talking about aluminum. Let's look at B now. Again, we're looking at our last filled sublevel, but once you get into the D, things start actually occurring out of order. So if we look at this, we need to figure out which is the last filled out of these 3. So again, if you're reading the periodic table, you're going to read 4s followed by 3d followed by 4p. So this is the last filled sublevel. So we're looking at this for the 6th element in 4p, which is going to be krypton. So now let's look at C. Again, we have D, so we actually need to follow the off-by principle. We need to figure out which happens first, which happens last, 3D or 4S. So if you look at the periodic table, if we read it from left to right, 4S actually gets filled before 3D. So this time around, we're going to be looking at who is 3D7. 3D starts with scandium. The 7th element is cobalt. So just be aware that sometimes they group them by energy level, not necessarily in the order that they happen. So just make sure you're looking for that. All right, let's go ahead and look at 24. 24 says consider the elements bromine and phosphorus and neon. So which has 3 electrons in the 3p sublevel? So let's look at 3p. 3p starts with aluminum. Well, it can't be. Well, bromine has 6 electrons in 3p. Neon has no electrons in 3p. And phosphorus has 3 electrons in 3p. So I'm going to choose phosphorus over bromine because that follows the question a little bit more. Okay, so let's look at B. B says its highest energy level is completely full. Well, that means we have to be talking about a noble gas. The only noble gas listed there is neon, which has the 2nd energy level completely full. C says who has the highest occupied energy level? Well, bromine is down there in 4p, which is higher than phosphorus, which is in 3p, which is higher than neon, which is in 2p. So I'm going to go with bromine. All right, so now let's look at 25. 25 says, what is the maximum number of electrons that can occupy each of the first 5 principal energy levels? Well, the first energy level, which is n equals 1, only has 2 electrons in it. It only has a 1s orbital. Each orbital can only hold 2 electrons, so it's going to have 2 electrons. Okay, the second energy level has 2 sublevels. It has 2s and 2p. The s orbitals can hold 2 electrons. The p orbitals can hold 6 because there's 3 of them. So that means it can hold a total of 8 electrons. The third energy level, there is 2s, 2p, and 3d. 2s or 3s can hold 2. 3p can hold 6, and 3d can hold 10. So that means it can hold a total of 18 electrons. Let's look at the fourth. The fourth can have a 4s, 4p, 4d, and 4f, which means it can hold a total of 32 electrons. Okay, but we need to go all the way to the sixth, so we have to do the fifth. The fifth is very similar to the fourth. It has 5s, 5p, 5d, and 5f, so it can again hold 32 electrons. However, in the sixth energy level, it no longer has F. Again, I'm just looking off my periodic table. We color-coded it. If you look at the sixth energy level, we can see 6 with, on mine it's 6 with yellow, that means it's 6S. I also see 6 orange, which means 6D, and I also see a 6 blue, which means 6P. So we have 6S, 6P, and 6D, which means this one can only hold 18 electrons, very similar to the third energy level. Again, none of this needs to be memorized. Everybody can count to 32, which is the highest you need to be able to count. Use your periodic table. Learn how to read it. So hopefully this helps for your test tomorrow. Please let me know if you don't understand something or if you need a little bit more help.